So in this lecture video, we're going to talk about multiplying and dividing fractions. So first let's talk about how we do that. How do you multiply fractions? So we normally teach concepts like addition and subtraction first, almost always, and then we move on to multiplication and division. Okay, but multiplying fractions, at least in my opinion, is actually easier to teach than addition and subtraction because you don't have to worry about common denominators. You just multiply straight across the top and straight across the bottom. Why do we do that though? The reason we do that is the concept of repeated addition. That's all multiplication is. We describe multiplication as just simply adding the same value repeatedly. So when we teach whole number multiplication, that's what we say, right? If we're teaching 2 times 3, we're teaching that there are 3 2's being added. Okay, so let's go ahead and jot that review question down. Let's do a different one though. If I say 4 times 3, that is the same as literally 4 3's, right? So 3 plus 3 plus 3 plus 3. It's the same as adding 3 4 times. And of course we know that answer is 12. So when we look at multiplication, it's often not that much different when we talk about fractions. So let's talk about 3 times 1/4 using repeated addition. So in other words, this is what I want you to think. You're adding 1/4 3 times. Okay, so if we're going to use our area model, you're literally going to show 3 different pieces that are each of 1/4 in size. So we have a 1/4 here, here, and here. So we literally have a 1/4 of this whole plus a 1/4 of this whole plus a 1/4 of the last whole, and if we combine those all together we get 3 of them, of course. So the answer would be 3/4. So it's fairly easy to talk about whole numbers being multiplied by fractions. Admittedly, it is a little more challenging to talk about a fraction multiplied by another fraction. So what if I asked you to show a 1/2 times 3/4? So let's talk about what our think statement would be. We're literally thinking of 1/2 of 3/4. So my suggestion on this would be to start with 3/4 and then figure out a way to show half of it. Okay, so let's show 3/4 first. I think we can all agree that that is 3/4. Okay, but now we need to take half of that. So over off to the side, we're going to take half of what we already have. And for that, I'm just going to darken in the half. Of 3/4. So in other words, I'm going to split it again going the other way. That's kind of been a strategy. Okay, and notice Here would be half of that 3/4, and here would be half of that as well. So I'm just going to darken it in so that my picture really shows exactly what the answer is. So if you darken that, remember fractions are the pieces I have on top. So how many pieces do I have? 3. And then how many pieces make a whole? Notice 8 pieces make a whole in this case. Now clearly this picture model, this area model, we wouldn't really use this for problems with really large denominators. Okay, that's not what it's intended for anyway. So kind of keep that in mind. All right, now we know that, hopefully we know that multiplication is what we call commutative, which means it doesn't matter which order we multiply things in, we'll get the same answer. So I want to show the same problem as in example 2, but maybe think of it the other way. So written like this, we're going to think that we want 3/4 of a half. So for this one, notice we would start with 1/2. Okay, so let's do that. We'll start with 1/2. So I'll start with a half, and then we'll take 3/4 of that. So I'm going to say we'll darken 3/4 of the half. Okay, so to get 3/4, we're going to have to split this shape up into fourths. So I'm going to split it up kind of like this. So notice this is a fourth, this is a fourth, this is a fourth, and so is this. But I only want 3 of these fourths, so I'm just really careful to only darken in 3 of those. I'm going to make it really, really dark because I kind of made the other one a little bit dark there too. So notice we get the same answer, which we expected, right? We know if we change the order in which we multiply, we should get the same result. All right, so one more and then we're going to look at division. I want you to try this one on your own. So if you can, I want you to pause the video, see if you can do it on your own, and then you can compare your answer to mine. So I want the think statement and everything. So our think statement is, hopefully you paused that and worked it out, 2/3 of 1/4. So what am I going to start with? I'm going to start with 1/4. I'm going to try to shade it a little lighter this time. Start with a fourth. Okay, and then we're going to darken how much of it? 2/3, right? So we're going to darken 2/3 of the fourth. So I'm going to say of the 1/4. So if you partition it off the other way, you get 1/3 here, here, and here. Okay, but we want 2 of those thirds. So we want 2 of these. So I'm going to make that real dark. So in the end, the answer is, how many pieces do I have that are darkened? 2. How many pieces make a whole? 12. Okay. Now in this case, I would want you to simplify this. So 2 goes into both of those, so I would want you to say 1/6. Let me slide that up, sorry. All right, so that's multiplication. Let's look at division. So if you can get out the rest of the handouts, there was 2. One of them says division of fractions without inverting, and then the other one says exploration 5.12, an alternative algorithm for dividing fractions. Okay, we're going to look a little bit at both of those. Really, the division of fractions without inverting worksheet just kind of tells you the method that I'm about to show you in the notes. But the other one has some example problems we're going to look at. So let's talk about division. So what's the rule for dividing fractions? Okay, the rule, in my opinion, is strange, right? And, you know, I've been teaching a long time, and honestly, students forget this rule because they don't understand why it's so weird, and they forget it easily. So the rule is you're supposed to flip the second fraction and multiply. A lot of teachers teach this little kind of short phrase. They say same, change, flip. Okay, so the reason we have to do that is, again, the piece sizes must be equal. But I'm going to show you an alternative method to this same, change, flip rule. It's not that it's that difficult to do for our students if they remember it, but that's the key. They often don't remember it. All right, so let's take an easy example and talk about why it is that division works out the way it does. So if I ask you to divide 1 by 1/2, I'm really asking you how many halves does it take to get to a whole? Okay, so how many halves does it take to make a whole? The answer, of course, is 2. Okay, notice if we would have flipped that second fraction and multiplied, we would have had 1 times 2 over 1, or 2. So sometimes we can use this strategy. So let's look at the like a picture model first. So for division, we will use an area model. But I think a line model actually works nicely with division too. So we haven't shown any of the other operations with line model, but I want to show a line model with division. And rather than repeated addition like we did for multiplication, this is just repeated subtraction. So I want to look at one problem in both of these ways, using both the area model and the line model. All right, so I'm just going to say use both models to show 2 divided by 2/3. Okay, so the first thing you would do is start with 2. So we have 2 wholes. Okay, and we're going to separate those into thirds because that's the denominator that's present. Okay, so the question literally is, how many 2/3 does it take to make 2? Okay, and I just use different colors for this. So here's 2/3, right? And we're literally just going to count how many that is. So this group is 1. Okay, I need another 2/3. Okay, so this group is 2. So far I'm at 2 groups of 2/3, right? And then last but not least, I've got a final group, right? So how many times did it take me to get to reach 2 when I was counting by groups of 2/3? The answer is 3. Okay, so this is the first model, okay, the area model. So the number line model is very similar, but I think it is important to show here because some of us need to work on our numbering and fractions a little bit. So here is 2, and we're going to ask the same question. How many 2/3 did it take to reach 2? But just like with the area model, we need to split the number line into sections of a third. And the reason we need to do that is because that's what we have on our sheet. So rather than saying 1 1/3, I'm going to call this 4/3. So think of it like 0 thirds, 1/3, 2 thirds, 3 thirds, 4 thirds, 5 thirds, and then that would literally be 6 thirds or 2. And then we're just going to do the same thing, okay? So this represents 2 thirds, right? So that's my first instance of 2 thirds. Okay, this is also 2 thirds, so that's 2 instances of 2 thirds. And then finally the third. Okay, so not surprisingly, we got the same answer since it was the same problem, just shown a different way. So this method works nicely when you have whole numbers involved. Okay, so I want you to go ahead and take out exploration 5.12. Okay, the one that says an algorithm for dividing fractions. Okay, and we're just going to look at a couple of these. So this is worksheet exploration 5.12. So if we don't cover one of them and you want to look at it later, that would probably be a good idea. All right, so let's look at number 2 on the worksheet. Okay, so let's kind of read that together. So number 2 says, Chin has 2/3 of a gallon of gasoline, and each time he mows the lawn, he uses 1/6 of a gallon. How many times can he mow the lawn before buying more gasoline? Okay, so the question really is, and you have to be able to break this down, the question is how many 1/6 of a tank is he going to have before he reaches the maximum amount of gas he has, which is what? 2/3? Okay, that's really the question. How many 1/6 is it going to take to make up 2/3? So we need to start with 2/3. I'm going to make this rectangle kind of bigger because I might need to kind of split this up in some way. So if this is his gas tank, if his gas tank is rectangular, which it wouldn't be, right? But we're going to make it easy with our drawing. Okay, the problem is that I don't really know how to take away or count 1/6 in here. Okay, so you need to think of some way that you can partition or split this up differently. Okay, by the way, this whole thing is 1 gallon of gas, but I only colored in 2 of the thirds because that's all the gas he has. Okay, so how could I split this so that I would be talking about 1/6? Notice if I do this, now each square or rectangle represents 1/6, and then I can just count how many times it took me to reach the whole level of gas, right? So 1, 2, 3, 4. Okay, so the answer is literally 4. Okay, let's do one more and then the rest you could kind of work on your own. Example 5. Jonah has 3 3/5 pounds of dog food. Each day his dog eats 2/5 of a pound. How many days worth of dog food does he have? Okay, so he has 3 3/5 dog food. So again, I'm going to use an area model. I definitely want you to be able to use a line model too, but I usually think an area model is easier. Now notice I drew 4 whole units, and I'm going to split these up into fifths. Okay, so let's talk about how much he actually has, right? So here's where you have to be really careful. He doesn't have 4 full bags. He has 1, 2, 3 full bags and then 3/5. So I'm going to go ahead and split this up right here. Like, we need to stop right here. This is where 3 3/5 is. But then the question is, every time he eats, right, he's eating 2/5. So how many 2/5 does it take to get to 3 3/5? That's the question. So if you just have two colors, you can kind of alternate it here. So here's 2/5. So that'll be a count of 1. And then you'll just kind of alternate. Here's another 2/5. So that's a count of 2. And then so on and so forth. So here's 3. So notice this problem was almost like the numbers were almost a little too big for it not to be tedious, right? But we muscled through it. Okay, so how many times did we count that we had 2/5? 9 times. Okay. So just keep in mind that we also could have used the line model. I just chose not to for time reasons mainly. Okay, so let's look at another method for dividing fractions. In other words, let's say that we are kind of confused, or our students aren't really responding to the same change flip thing, like they keep forgetting it, or maybe we just don't understand why we're doing it anyway. Okay, so the other alternative, or another alternative, is to get a common denominator. And then divide across the top and bottom. The reason I think this method is better is because your students, by the time they get to division, they'll already know how to find a common denominator because they'll already have learned how to add and subtract fractions. And then as far as dividing across the top and the bottom, that's how we handle multiplication, right? So all of the skills involved in this method they'll already have. Okay, so let's look at a couple examples, and I think you'll see this method actually works pretty nicely. Okay, so if you were doing 3/4 divided by 1/2, instead of flipping anything or doing anything like that, we're going to find a common denominator. And notice the LCD in this case would be 4. Okay, so we're going to multiply top and bottom of the 1/2 by 4, and then we're going to end up with 3/4 divided by 1/4. Okay, and now we're just going to divide across. Sorry, not 1/4, right? 2/4. Sorry about that. And so because we have a common denominator, notice what we're always going to get in the denominator. So we're just going to get 3 divided by 2, right? Because that doesn't really work out. And then over 1, okay? Or just 3/2. Notice the over 1 is kind of unnecessary because it'll always be over 1 since you have a common denominator. So if you wanted to, you could have your students change that to 1.5. Okay, so let's look at one more, and then we'll look at kind of a little small variation of this method. It's similar, but just a little different. So 5/7 divided by 2/3. So instead of changing it to 5/7 times 3/2 like we traditionally would have done, let's talk about what the LCD would be. So what's the first number that 3 and 7 both go into? The answer is 21. So notice both of these are going to need to be multiplied by something. So if I multiply by 3 and by 7, then I'm going to get 15 over 21 divided by 14 over 21. So in the end, I get 15 over 14 over 1. You know, if you don't like the fact that there's a fraction within another fraction, you can drop off the over 1, right? Since we're always going to have the over 1. So we would get 15 over 14, or 1 and an extra 14th. Okay, so all we did here after we found a common denominator is we divided across. All right, so it's worth noting that you actually don't always have to have a common denominator. And you might find you like this alternate method better, okay? The alternate method, so I'm going to put a 2 there since it's alternate from the number 1 I have up there. The alternate is to make sure that the first numerator and denominator are divisible by the second. I'm going to give you some examples of that. In other words, as long as you can divide straight across the top and the bottom nicely without getting, you know, decimals and stuff, then this method actually works great. So let's look at a quick example of that. So like if you had 25 over 4 divided by 5 over 2, then you don't actually have to get a common denominator here, okay? You can strictly just divide across, because notice both of the divisions would come out nicely. So 5 divided by 5 is 5, and 4 divided by 2 is 2. So our answer is literally just 5 over 2. Or if we wanted a mixed number, we could have our students change it to 2.5. All right, so before we end division here, I want to talk about why does the same change flip rule work. So I taught you a different method, okay, that I'd like you to consider teaching your students other than same change flip. But we're going to talk about why it works simply because it's just a common way to teach it. It's still probably the most common way to teach that topic. And your school district might, you know, have rules about how they want you to teach certain things, okay? All right, so let's talk about the old traditional way most of us learned, okay? We would say that this changes to 5/7 times the reciprocal, right? So times 3 over 2, and we get 15/14. Okay, notice that's the same problem that I had up top, okay, for example 7. Okay, so this is the how, but my bigger question is, why does this work? Okay, it seems odd, and how come it works? All right, so to show why it works, we're going to show 5/7 divided by 2/3 as a fraction instead of with the division symbol. And so if we didn't want a fraction within a fraction, we would multiply by the reciprocal in the denominator. Now notice why we would do that. That will leave us with 6 over 6 or 1 in the denominator. But whatever we do to the denominator, we have to do the same thing to the numerator. And the reason we have to is because that maintains the same value, right? It's the same as multiplying by 1. So let's talk about what that gives us. Now if we multiply top times top, we'll get 5/7 times 3/2, right? But if we multiply bottom times bottom, we'll get 6 over 6 or 1. So notice in the end, we end up with 5/7 times 3/2, which is the very thing we changed it to. So I want to be clear kind of what I'm showing here. So here, I'm showing that I started with my original problem. So I started with 5/7 divided by 2/3. Okay, and then I did some arithmetic, and I ended with the method that I'm normally taught. I ended with 5/7 times 3/2. Okay, in other words, I ended where I was multiplying the reciprocal of the second fraction, or the flipped version if we haven't taught them the word reciprocal yet. Okay. So I might ask you on the homework to show me why and how this rule works. Okay, so here's the how. We change the second fraction to the reciprocal and we multiply. But probably more important to me is that you understand why. Okay, and that's because if we multiply the denominator by the reciprocal, we do the same to the top, right? And then we end up with that multiplication over 1. Okay. Notice in this instance, it's not necessary to really talk about the answer, although the answer would be 15/14. We already tried that here. All right, so I want you to try one on your own. Okay, so I want you to try to show how and why. I want you to show me why is 1/2 divided by 2/3. Why is it the same if we do 1/2 times 3/2? Okay, so we change the second fraction and we change it to multiplication. So pause the video and see if you can do both parts, the how and the why. So hopefully you paused it and worked on that on your own. So the how is that 1/2 divided by 2/3 is the same as 1/2 times 3/2. And then we just multiply across, right? We get 3/4. So if we're going to explain what we did, let's make sure we do that. Okay, so like I said, it's not that this method is difficult, it's that a lot of students forget it. Okay. All right, so let's get to the why. The why involves us starting with what we were given. Okay, so you start with your original problem. So you start with 1/2 divided by 2/3. Okay, and then you're going to multiply by the reciprocal of the denominator. Okay, notice we're allowed to do this because it's the same as multiplying by 1, and I would want you to label this step that way. And then we're going to get 1/2 times 3/2 over 1, right? Because 6 over 6 is just 1. So notice we're ending with 1/2 times 3/2. And again, we already showed the answer up here, so it wouldn't be wrong if you again showed the answer. I just don't think it's necessary. So notice we ended with the 1/2 times 3/2. Okay, so the why step is more why are you allowed to change the division to the multiplication, honestly, than it is really about what the answer is.